Welcome to the 12th lecture of EDC. Well, we are still in the first module, basic semiconductor physics. Now with this lecture video, we are going to start a new chapter called doping. Now before getting to the doping subject, let me revise a couple of things. As we know, the classification of semiconductor has done in two ways, and we made a separate video for this classification of semiconductor. Let me quickly go through this thing because everything is related with this thing. Okay, the classification of semiconductor in terms of when two elements combine with each other, us basis में semiconductor classification is two type, element types semiconductor and compound type semiconductor. So element types semiconductors are germanium and silicon. If you take only group 4 elements, that will be element type of semiconductor. When your third group element and fifth group element, like when they combine with each other, they produce a compound type semiconductor. We know this thing, right? Now moving on, there is other way that we can divide a semiconductor two ways. Basically, this is a three ways. I'll explain that. So semiconductor classification in terms of the addition of impurity, it is divided into two types. One is pure, another one is impure. Now impure is popularly known as extrinsic semiconductor. I'll come to this impure thing, but let's understand this pure wala subject. As I have discussed in a previous case, actually semiconductor is divided into three categories: intrinsic semiconductor, pure semiconductor, and impure semiconductor. When any interviewer asks you what is the classification of semiconductor based on their impurity, addition of impurity or the presence of impurity, you tell them semiconductor is divided into three categories. One is intrinsic semiconductor, another one is pure semiconductor, another one is impure semiconductor. What is the basic difference between intrinsic and pure? The interstitial impurities, interstitial impurity in case of intrinsic semiconductor, but in case of pure semiconductor there is no interstitial impurities. So in interview you can answer this, but in our analysis in the further class we are going to consider only two categories. One is pure, another one is impure. Where pure is completely pure, there is no impurities, there is no interstitial impurities, nothing is there. So we are classifying this semiconductor into pure and impure. Whereas impure is there is the presence of impurities is there. So in case of impure there is a presence of impurities, but in case of pure there is nothing is there. There is no interstitial impurity. Now let's get into doping chapter. Now what is doping? Now let's understand this thing. Why we do doping? What is the actual necessity of doping? Doping का मतलब क्या है? So let's understand पहले what is doping. What is doping? It's a very simple thing. If you add impurities into a pure type semiconductor, in your pure type semiconductor, if you add impurities, popularly known as dopants. If you add dopant element as impurity into pure semiconductor converted into impure semiconductor, or popularly known as extrinsic semiconductor. Now this process of addition of impurity, the process of addition of dopants is nothing but called as doping. So why doping is necessary? Why we do doping? हमारे pure को लेके काम नहीं चल रहा है क्या? We are doing the doping thing, उसको impurity लाओ add करो. Now the basic need of doping is in one line answer. If anyone asks you, so tell them doping increases the conductance of semiconductor. Through the help of doping, we increase the conductivity nature of semiconductor, the conductance of semiconductor. But if you take pure semiconductor, so the availability of charge carrier, the availability free चार्ज कैरियर मीन्स ये इलेक्ट्रॉन हो सकता है, ये होल हो सकता है. सो अवेलेबिलिटी ऑफ चार्ज कैरियर, फ्री चार्ज कैरियर इज नॉट देयर इन केस ऑफ प्योर. बट इफ यू ऐड प्योर के साथ, इफ यू ऐड सम इम्प्योरिटीज if you add some impurities, there will be availability of electron and availability of hole. So how it happens? So by making availability of charge carriers. Now moving on to our next slide. Here you will get a brief clarity on प्योर सेमीकंडक्टर एंड इम्प्योर सेमीकंडक्टर. एक एक करके ब्यूटीफुल पॉइंट्स हैं, वो सारे समझने की कोशिश करते हैं जो हम क्लीशेनेस को पकड़ के उसको इग्नोर किए हैं. प्योर सेमीकंडक्टर एंड इम्प्योर सेमीकंडक्टर. इम्प्योर सेमीकंडक्टर पॉपुलरली नोन एज एक्सट्रिंजिक सेमीकंडक्टर. प्योर सेमीकंडक्टर मीन्स देर इज नो impurities, there is no interstitial impurities. But impure semiconductor means if you take a pure semiconductor plus if you add some impurities, which is popularly known as dopant element, this became impure semiconductor or extrinsic semiconductor or extrinsic. In case of pure semiconductor, if you increase the temperature value, in case of pure semiconductor, the electrons in bonding level break the covalent bond and move from valency band to conduction band, causing the free electron availability on conduction band. Now look here carefully. If you increase the temperature, electron will break their bond. It will not happen at 0K. 0K में नहीं होगा. अगर आप increase करके 300K पे लाओगे नहीं होगा, because this is a room temperature. Okay, room temperature में ये नहीं होगा, ना कि 0K में होगा, ना कि room temperature में होगा. If you increase the temperature larger than that of room temperature, at that point of time electron will shift from valency band to your conduction band, or we can say bonding level to your anti-bonding level. It will start moving from bonding level to anti-bonding level in case of intrinsic semiconductor. So pure and intrinsic, we are taking it as one category called as pure. Okay, so in this case, if you increase the temperature at high temperature, I can say at high temperature conduction possible, cause in high temperature electron availability at conduction band will be more. But in case of extrinsic semiconductor, if you see, there is no need of rise in the temperature, because there is no need of rise in temperature, because at 0K, even at 0K, not even at room temperature, at 0K the free electrons are available. So extrinsic semiconductor is basically divided into two categories. One is N-type semiconductor, another one is P-type semiconductor. We'll go into each and every type of semiconductor one after another. Our next lecture video will be on N-type semiconductor. So the basic point, the basic idea behind our discussion is, let me tell you it in a very simple way. One is pure and one is impure. Okay, in a very simple language. In pure, you can't get conductivity nature at room temperature and pressure. But in case of impure semiconductor, even if at 0K, forget about room temperature तो 300K होता है. Forget about room temperature, even if at your 0K also, you get the conductivity, you get the free electron availability near the conduction band in case of impure semiconductor. But in pure semiconductor it is impossible. Okay, that is the entire point of the discussion, of our entire discussion. That is the only point. Okay, now moving on to our last point. In pure semiconductor, free electron movement in anti-bonding level and hole movement in bonding level causes the total current by electron and hole. So in case of pure semiconductor, always remember, free electron is available. Now the free electron movement in anti-bonding level happens and hole movement in bonding level happens only if you raise the temperature. Okay, at high temperature. So at high temperature, you got this point. Thank you so much for watching. See you in our next lecture, that is N type of semiconductor. Till then, bye.